High electrical demand can turn a minor frame fit problem into overheated wiring, BMS shutdown, damaged connectors, or an unstable battery mount. In a 72V conversion, triangle and cuboid packs may use similar lithium chemistry, but their geometry creates very different limits for capacity, current delivery, cooling, service access, and structural support. A triangle battery is typically matched to the main cavity of a bicycle-style frame. This location keeps mass near the center and can preserve more balanced handling than a rear-mounted pack. It also uses space that might otherwise remain empty, making the format practical for urban conversions, moderate off-road use, and projects that retain conventional bicycle geometry. That integration comes with constraints. A triangular enclosure can restrict cell arrangement, BMS placement, discharge wiring, insulation clearance, and connector direction. If the frame cavity is tight, the battery may be pressed against tubing or installed without adequate strain relief. High controller demand further reduces the available safety margin. Voltage compatibility does not confirm that the BMS, cells, cables, and connectors can support the required continuous and peak current. A cuboid stealth bomber-style battery is designed around a deeper rectangular bay commonly found in enduro-style frames. The regular shape can provide greater freedom for cell layout, enclosure construction, bus structure, high-current wiring, and BMS placement. It can also offer more capacity headroom where the frame is built to support a large enclosed energy module. Greater size does not remove installation risk. A heavy cuboid pack requires firm support across appropriate contact areas, protection from movement, and clearance for cables and servicing. Weak mounting points can be stressed during braking, pothole impacts, jumps, or transport. A pack buried too deeply in the frame may also become difficult to inspect, disconnect, or remove. Range should be evaluated through usable watt-hours and operating conditions rather than enclosure size. A 72V48, a battery has nominal energy near 3456 Wh, but actual distance depends on rider weight, speed, terrain, tire resistance, temperature, acceleration, and controller behavior. Aggressive use of a high-power hub motor can consume stored energy far faster than moderate commuter operation. Pack geometry affects range indirectly by limiting capacity, influencing thermal conditions, and affecting voltage sag under load. Current capability is the more immediate concern. The controller may request bursts beyond what the battery or BMS can safely supply. A triangle pack with limited BMS space may activate protection or experience heat stress despite matching the system voltage. A cuboid pack may accommodate stronger current paths, but shape cannot substitute for documented continuous and peak discharge ratings. Selection should begin with physical measurement of the actual frame cavity. Confirm enclosure dimensions, mounting points, cable exit direction, connector location, padding requirements, and removal clearance. The battery must fit without compression, sharp cable bends, or pressure on connectors. Heat-sensitive areas also need suitable clearance for the expected riding load. Next, compare controller demand with the documented BMS and battery discharge capability. Verify voltage, amp-hour capacity, watt-hours, charger compatibility, connector type, fuse strategy, cell information, and thermal behavior. Riding conditions such as hill climbing, cargo, sustained speed, and off-road shock should be included in the assessment. Documentation also affects procurement risk. Transport records, safety information, certification references, warranty terms, cycle life assumptions, and after-sales support should be clear. Supplier responses should connect the battery specification to the intended frame, controller, motor, and operating profile rather than simply repeat a capacity label. Triangle packs are often the stronger fit for compact bicycle conversions that prioritize central mass and straightforward integration. Cuboid packs are generally better aligned with enduro frames designed for greater capacity, current headroom, and enclosure protection. The correct decision is determined by mechanical fit, verified electrical capability, thermal clearance, secure mounting, and service planning, not by which battery appears larger.